Hey guys, so we are coming back now to a different type of sequence, and if you remember what I said by geometric sequences were sequences that instead of adding on a certain amount each time, you were multiplying by a certain amount each time. And the thing that you're multiplying by is called the common ratio, and the letter that we use for the common ratio is r. So I've written here that a geometric sequence is one in which there is a common ratio between the terms. So you can either just have a look at the sequence and just say to yourself, okay, well I know that 3 times 2 is 6 and 6 times 2 is 12. Or there are some other techniques that you can do that might help you to figure out what the common ratio is. So this kind of one is pretty simple, right? If we're going to try and say what the common ratio is here, we can clearly see that this sequence is a doubling sequence. This one though, you've got to be careful because the common ratio, although it might look like it's actually getting smaller, then means you're going to be multiplying by something that is smaller than 1. So if you want to find out what did you multiply this by to get to this, well, you can go the other way around and I can do this one divided by this one. So I've just got 18 divided by 27, and 18 divided by 27 is 2 over 3. So this time the common ratio is 2/3, and let's just see if that makes sense. 27 times 2/3 is 18, 2/3 of 18 is 12, and 2/3 of 12 is 8. So the next one would be 2/3 of 8, which would be 16 over 3. So they don't have to be integers that we have here, okay? Now again, if you want to find out what the common ratio is, it looks like this time as you go across, it's halving each time. So the common ratio of r is going to be a half, or you might say that r is equal to 0.5. And again, you can just do this one divided by the previous one, or this one divided by the previous one. This is a weird kind of common ratio because actually this is what we call an alternating sequence. It is an alternating sequence because it's oscillating, which means kind of going back and forth between, oscillate like a heartbeat, between positives and negatives. So it's going 5, minus 5, 5, minus 5, 5, minus 5. So if you think about what these are being multiplied by each time as you go along, hopefully you can quickly spot that it's just being multiplied by minus 1. So we've got that the common ratio there is minus 1. You can, of course, have geometric sequences that are algebraic. So best thing to do is just to deal with the algebra part first of all. So it's going x squared, x cubed. Right, well that must mean that the common ratio has obviously got some x each time it's being multiplied by x as we go across. It's also being multiplied by minus 2 each time. So you can see here that it's been multiplied by a minus 2 as well, and then when you multiply minus 2 by minus 2, you do get a positive 4. So we get the common ratio is minus 2x. If you find that difficult to spot, you can just do the same trick that we did here, where we did 18 divided by 27. So you could do minus 2x squared divided by x, and clearly that is going to give you the minus 2x. And it works if you do this one divided by this one as well. You get 4x cubed divided by minus 2x squared. Well, the x squared will cancel with the cubed, and then 4 divided by minus 2 is minus 2, so you do get your minus 2x. Similar thing here, we're going 1p, p squared, p cubed. Pretty easy to spot this one, that the common ratio is just p. This one though, got to be a bit more careful. I would recommend doing this one divided by this one. It's just the easiest way to spot what the common ratio is once you know it's geometric. So you can either do minus 1 divided by 4, and then we go straight to what the common ratio is, meaning it's multiplied by a quarter. Or you could have done this one, 0.25 divided by minus 1, which again is going to be minus a quarter. And you can check that by multiplying by minus a quarter each time, just to see that it works. Okay. So we're going to find what the nth term is of a geometric sequence. Bearing in mind this thing here is what the nth term is. Well, you can see that the first term is a. To get the second term, you multiply it by the common ratio. The third term, you multiply this one by the common ratio, hence it goes from AR to AR squared. And you keep doing that pattern. What you notice is that for the nth term, you are doing AR to the power of 1 less than the nth term. A bit like when you had for the arithmetic sequence, we had the n minus 1d. It's got that same kind of feature to it. So if you look here, second term, power of 1, third term, power of 2, fourth term, power of 3, nth term, power of n minus 1, 1 less than that. So the nth term of a geometric sequence is AR to the n minus 1. And this is something that you don't get given. This is something that you need to know or to memorize. Some people will just be able to have like the logic behind this. Some people will like to memorize this kind of fact. I think I'd probably just have like a combination now from having done it so many times. There's a logic part to it, but there's also like a memory aspect as well. So let's use some of this. It says that the second term of a geometric sequence is 4, and the fourth term is 8. The common ratio is positive. Find the exact values of the common ratio, the first term, and the 10th term. So we're going to write down this information that they've told us. They've told me that the second term, so U2 is 4, and they've told me that U4 is 8. Well, I know that the second term will be AR to the n, which is 2, minus 1. So in other words, 4 equals AR to the power of 1. Now here we can say that 8, which is the fourth one, is going to be AR to the AR to the n minus 1. So we get that 8 is equal to AR cubed. Now I have this equation here, and I have this equation here, and we have simultaneous equations. Now this is a simultaneous equation we're actually going to have to solve. I can't put this in a calculator, so if I call this one number 1 and this one number 2, just have a quick think to yourself, how would you solve these simultaneous equations the most efficient way? Okay, the best way to solve these ones is to do the one with the larger power divided by the one with the smaller power. So if I do AR cubed divided by AR squared, in fact I'm just going to write it out, we have AR cubed divided by AR, not AR squared, sorry, AR, that is equal to number 1 divided by number 2. So the a's will cancel, and you have r cubed divided by r, so we get r squared. And 8 divided by 4 is just 2. So r is the square root of 2, but it could be plus or minus. However, they told you that the common ratio is positive, so we're going to actually just take the positive one for this. We're just going to take the square root of 2. So now we want to find out what the first term is. This was our bit here that was to work out what the common ratio was. And now we're going to find out what the first term is. We're actually just going to find out what A is. So using equation 2, I'm now going to say that 4 equals A multiplied by root 2. So A is equal to 4 divided by root 2, which is 4 root 2 over 2, which is 2 root 2. So the first term is root 2, and the 10th term that we're now going to work out, we're going to say what U10 is. Well, we know that U10 is AR to the 10 minus 1, AR to the 9, which is going to be 2 root 2 times root 2 to the power of 9. I'm going to be super lazy and just put this in my calculator. So we have root 2 to the power of 9 times 2 root 2, and we get 64. Now, I'm actually just going to write out what the sequence is. It doesn't ask us to do this for the 10th term, but I just like to see what's actually happened here. So we said that the first term was 2 root 2. If we multiply this by root 2, we get 4. Is that right? 2 root 2. Yeah, times root 2, of course we do. We get 4. Then we would get 4 root 2. Then we would get 8. Then we would get 8 root 2. Then we would get 16. Then we would get 16 root 2, etc., etc. So we've got the first, the second term, that's what they said. The third term, the fourth term, 5th, 6th, 7th, 8th, 9th, and 10th is going to end up as 64. Okay? So here we go. We've now got something this time. It was a bit like we did this with arithmetic, and now we're going to be doing it with the geometric kind of sequence as well. And it's going to relate to the idea of how we find out what the common ratio is. So it says these three numbers, 3x and x plus 6, form the first 3 terms of a positive geometric sequence. So we've been told it's positive and it's geometric, so we can go straight in and do some calculating here. We want to find out the value of x. Well, have a think about how we found the common ratio on this. This one, we did this one divided by this. And we did this one divided by this. So you can use that same technique to find the common ratio. We know that the common ratio for this is going to be x divided by 3. We're doing this one divided by this one. But we also know that the common ratio is x plus 6 divided by x. So this divided by this and this divided by this, because it's the common ratio, they have to be the same as each other. So we get that x over 3 must be equal to x plus 6 over x. And now if I solve this equation, I get x squared equals, multiplying this by the x and multiplying this by 3, I get 3x plus 18. So we get x squared minus 3x minus 18 equals 0. And then we think about, does this factorize? Yes, I think this is going to factorize. So we get that x minus 6, x plus 3 equals 0. So either x is equal to 6 or x is equal to minus 3. But it tells us actually that this is a positive geometric sequence. So it can't be a minus 3 here. So it's actually going to have to be x equals 6. But it says, but geometric sequence is positive, so x equals 6. Let's just see what would have happened though if it was the other one. Let's actually do both of them as sequences. So first of all, if x is equal to 6, it would go 3, 6, 12. So you can see that the common ratio looks like it's going to be 2. It's just doubling each time. And let's do this one in black. If x was minus 3, it would have gone 3, minus 3, 3. So you've got a common ratio of minus 1. It's just an alternating sequence or an oscillating sequence that we have there. So that was part A of the question. And now part B of the question says find the 10th term in the sequence. So we're trying to find out what U10 is, which we know is going to be AR to the 9. So we can clearly see that A in this case is 3, and we've worked out that the common ratio, we actually haven't worked out what the common ratio is yet. Maybe we should have a think about that. So our first term is 3, and we're going to do our common ratio to the power of 9. Well, the common ratio is just x over 3 that we've got over here. So our common ratio is going to be 6 over 3, which is 2. So it's going to be 3 times 2 to the power of 9. And 3 times 2 to the power of 9 is 1536. So we get 1536 for this particular, the 10th term in this sequence. It's a doubling sequence. It's getting twice as big each time we move across. Okay, you can also use inequalities and the nth term stuff together. So I have this geometric progression. This is literally just another word for a sequence. So please don't worry if you see a progression. It just means it's a geometric sequence. And it says, what is the first term in the geometric sequence to exceed 1 million? So it's actually asking for what is the first number that gets bigger than 1 million, not what's the position that it is. So our sequence that we should do here, I think we should extract some of the information that we know. So some of the things that we know about this sequence is that A is equal to 3, and we know that R, the common ratio, well, you can do 12 divided by 6 or 6 divided by 3. The common ratio is 2. So that means that our nth term, un, is a times r to the n minus 1. A times r to the n minus 1. You've got to put this times in here, otherwise you get this, which obviously doesn't make any sense at all because it looks like 32 instead. So what we shall do is we want this thing, which is 3 times 2 to the power of n minus 1, we want this to exceed 1 million. Let's just check I put the right number in there. Good. So what we're going to do to this is we're going to divide both sides by 3. And then we're going to take logs of both sides. Okay, so if I take a log of this side, I'm going to use, shall I use ln? I love using ln, I'm always going to use ln. So I'm going to pull the power down, so I get m minus 1 ln 2 and ln of 1 million over 3. So n minus 1 has got to be greater than ln of 1, 2, 3, 4, 5, 6, 1 million over 3 divided by ln 2. You know you can't simplify this. So let's actually just get what that is as a number because I'm getting bored of typing that in, of writing that out, I mean. So it's ln of 1 million over 3 divided by ln 2. So that is that n minus 1 is greater than 18.3 blah blah blah. So that means n has got to be greater than 19.3. And because n has to be an integer, we're going to say that the first term is when n equals 20. So it's the 20th term. So it says, what is the first term that exceeds 1 million? So it is the first one when n is equal to 20. So I'm actually just going to say what the 20th term is. So the 20th term is 3 times 2 to the power of n minus 1, which is 19. Let's hope this one is bigger than that. So we're going to do 3 times 2 to the power of 19. And we get 1, 5, 7, 2, 8, 6, 4. Yep, that's definitely bigger than a million. What I might do, just to make sure that I've got this correct, I'm just going to try what U19 is, which would be 3 times 2 to the power of 18. You can pretty much see what this is going to be. So if I change it to 3 times 2 to the power of 18, you do get 786, 432, which is less than 1 million. So this is the first one that exceeds 1 million there. So I'm going to give you a chance to have a quick go at these two questions, and I'm going to go through them after you've paused the video to have a go at them, and then you're going to do exercise 3C for me, and then we'll come back together and we shall also do the sum of geometric series 2. So make sure you pause here. Okay, so it says all the terms in a geometric sequence are positive. That just helps us with our, if we have to take any square roots, we know if we're going to take the positive one or the negative one. The third term of a sequence, so U3 is 20, and the fifth term is 80. What is the 20th term? So really, before we do any of this, we need to find out what is A and what is R. Then we can find the 20th term after we've got that information. We always want to do this bit first. So that must mean that the 20 is equal to AR to the n minus 1, which is AR squared. And 80 is equal to AR to the 4. So that's 5 minus 1 to give you the 4. Now, do you remember what we did with these two equations? We could do this equation divided by this equation. So I'm going to do number 1 here and number 2 here. And I shall do number 1 divided by number 2. So on this side, I'll have my 80 divided by 20 equals AR to the 4 divided by AR squared. Well, the A's cancel, and you get left with R squared. 80 divided by 20 is 4, so R is equal to plus or minus 2. However, we've been told that the geometric sequence is positive, so we take the value of R as being the positive one, otherwise you'd get this alternating sequence that's going positive, negative, okay? Now, if we know that R is equal to 2, we should find out what A is equal to. So I'm going to just using equation 2. So I shall use 2, and I get that 20 is equal to A times R squared, which is A times 2 squared. So A is 20 divided by 4, which is 5. So we now know that R is 2 and A is 5. So the 20th term, which is U20, is going to be A multiplied by R to the power of 19. So that's 5 times 2 to the power of 19. It's going to be a big number. And we have, if I write this out carefully, 2,621,440. So it's a pretty big number. Okay, let's try this one. The second, third, and fourth term of a geometric sequence are the following. So carefully, it says this is the second, third, and fourth. So we need to eventually find out something to do with the first. And it first wants us to find out the possible values of x. Possible values of x, that means there's going to be a couple of solutions we could have here. So do you remember what we did here? We did this divided by this was the common ratio, and this divided by this was the common ratio. So my common ratios, there's me in the habit of doing vectors, underlining stuff. So my common ratio is x over 6 over x. But I also know that the common ratio I could have done, because they've given me 3 terms, could be 5x over 6 over x plus 6. So I can ignore this bit here really, and I can just solve this equation. So I get x plus 6 squared from multiplying these, and I'm going to multiply by these, which is 5x squared minus 6x. So left hand side, I get x squared plus 12x plus 36 equals 5x squared minus 6x. I'm going to get everything onto the right hand side, so I'll subtract an x squared, and get 4x squared. I subtract the 12x and get minus 18x. And I'm also going to subtract 36. Yeah, I'm lazy. I'm doing this calculator, even though I could divide by 4. Who really cares? We can do it like this. So my values for x are, this is all for a here, is that x is equal to 6 or x is equal to minus 1.5. Given that the common ratio is positive, find the common ratio. So we now know that the common ratio is positive. So I guess we better have a look and think about what happens when x is 6. So if x is 6, it would go 6, 12, and 24. But if x was minus 1.5, it would go minus 1.5, and then we've got 6 minus 1.5. You then got 4.5. I wonder if we can spot what the pattern is. And then we've got minus 5 times 1.5 minus 6, and then you've got minus 13.5. So it looks like the common ratio here is going to be a minus 3, but the common ratio here is a 2. So it must be, for this one, the common ratio is 2, and for this one here, the common ratio is 4.5. Oh, we could have gone straight over here. Silly me. Could have just worked out what the common ratio was like this. We could have just done 6 plus 6 divided by 6 to get 2, or you could have substituted in minus 1.5 into here, and it would have told you what the common ratio is, which is minus 3. So it says that the common ratio is positive, so this is our answer that we're going to use here, because we can't have that one as our common ratio. Hence, determine the possible values for the first term of the sequence. Well, it says that the common ratio is positive, so I don't really know why it's saying there's many values there. I think we should just say, because the common ratio is 2, to find out what the first one is, well, it would be the one that comes before this, so it's just going to be 3. There's no other answer that we could have for that one. It's just going to be 3. I think it's saying determine the possible values for the first term of the sequence if we had that the common ratio was minus 3. So we could also do this divided by minus 3 as well, which would be a half. So I guess it could be a half for this one, but it's really just talking about when the common ratio is positive, because it said that it is. So it looks like the first value is going to be 3, and now you can try some questions from exercise 3C for me. Okay.